Hi everyone, we're Team Golf and we've been working on the mixed reality PDF editor. So it's not particularly a revealing name, but what we aim to do is solve this problem. Lots of people like to print out documents that they've got to read, review them, go through them with a pen and annotate them, cross things out, underline, highlight, but there's no good way to get those annotations back into digital form. So what we've built is a system which can identify annotations on a paper document and apply them back onto the original PDF. Essentially, it can turn what's on the top left here, which is a scanned image, to what's on the right, which is a fully selectable, searchable PDF. So, how does this work? First stage is to align the scanned document in the middle with the original digital PDF on the left. To do that, we find the bounding box of each, and we match the corners. That means that any coordinates of an object on the left, we know where to put on the right. Over to Olga.
So now we would like to extract the changes that have been made to the original PDF. At first we tried to align them perfectly and take the difference from it, but with any small misalignment the data was terrible. So we made a restriction for our document to be black and white and our annotations to be in color. And here's an example of the result from taking color difference. As you can see, the result is really good, and there's little noise, and it produces data good enough for us to move on to the next stage, which is segmentation. So now we'd like to get coordinates of our annotations so we can analyze them individually. And thanks to the alignment stage beforehand, we know that the coordinates are going to correspond to the original PDF. So as you can see on this example, we managed to create very accurate bounding boxes for all our annotations with cluster detection. And the coordinates of the bounding boxes are then passed on to the identification stage, which we want our system now to take the annotations, crop them out, and tell us what type of annotation an image represents. And with our client, we decided to focus on the 3 types of annotations listed: underlines, highlights, and texts. So we crop the images out, we extract information about them, and these features are then used to classify them as one of these. Here's a diagram we generated from the decision tree that we've been working on extensively to help us with this classification. Unfortunately, although tremendous effort went into this stage, our results from it weren't reliable enough to use it in the final product. So here's an example of the outputs that our decision tree produced, and it had big problems with highlights and underlines. And because of technical problems, we ran out of time to actually improve its performance. So we instead worked around it with a few conditional statements that mimic the decision tree. And the final stage was to then apply the information we found throughout the pipeline to the original document. And in case we couldn't determine what sort of annotation it was, we would just overlay it as an image. And so with enough effort, here's a real example of an output that we managed to produce with our program. And yeah, even though there are still some flaws in our product, we believe that this is the beginning of a project that can be really beneficial to many professions. Thank you.